Yeah, you can clap if you like. Thank you. May as well get it now, I mightn't get it at the end. What I want to talk about is efficiency and effectiveness. I mean, I don't know how many talks I've given about nitrogen over the past 10 years, and you buggers still don't get it right. So we've just got to keep hammering away at it. When we talk about effectiveness and efficiency, we have to make sure we know what we're talking about. So here's the first question for you. You've seen this graph, fertiliser rate versus yield, any fertiliser, it doesn't matter, any crop, doesn't matter. Where's the highest efficiency? Is it between A and B, between B and C, C and D, or below D, above D? Who thinks the first one? Who thinks the last one? Who's not saying? Okay, when we talk about efficiency, what we're talking about is what you get for what you give. And in that first part, you're getting 2.5 tonnes for 5 units of whatever it is, and that's half a tonne per kilogram. Now, if you said, well, that's cheating a bit because you're not going from 0, but you're going, you've only got 2, so that's 4 tonnes per kilogram. That's a use efficiency. As you go from B to C, that's extra 5 kilograms, only gets you to 3.5 tonnes, so that's 3.5 tonnes per kilogram, or 0.2 tonnes on a marginal return, and so on. C to D, 15 kilograms, 4 tonne per hectare. And then above D, you get 20 kilograms, you get 4 tonnes per hectare, you don't get any more. So where is the most efficient place on that graph to put the first kilogram of nitrogen, or phosphorus, or potassium? Okay, here, 0. The most efficient way to use fertiliser is not to use any, okay? Because that's where you get the biggest return for the lowest input. But what's the problem with that? Is it effective? You're not getting effective. You're efficient, but you're not effective. And so that's why we have to make sure efficiency is important, but effectiveness is really what we're thinking about in a lot of cases. And we're thinking about dollar for dollar or kilogram for kilogram. Now, in your farm, on your clients' farms, what's this number mean? Kilograms per millimetre. No, it's Jake Merritt's number in the Essendon Football Club, but it is in fact 20 kilograms per hectare. How many farmers don't know that number, 20 kilograms per hectare per millimetre? Few? None? Everybody in this room should know, because that's been something that's been banged away. Every farmer and advisor knows that the water use efficiency we would target would be 20 kilograms per hectare per millimetre of water. But what about, say, for nitrogen? What's the efficiency we would target there? We can do that in a couple of ways. We can look at a partial factor productivity, which is that return on nitrogen in terms of grain, or we could look at how much nitrogen we move versus how much we applied. And this is the sum that every farm and every paddock can have done on it to get themselves aware of what's happening there. So, for example, if you looked across Australia and divided all the cereal production by all of the nitrogen that goes on cereals, you'll find that you get about 50 kilograms of grain per kilogram of nitrogen applied. And we get about 80% of that nitrogen that goes on is returned. Now, that doesn't mean that that nitrogen is all coming from fertiliser, because in fact quite a bit of it is going to come from legumes or pastures and so forth. But what we're doing here is sort of getting an index. In the same way we had 20, we could think about 50 as being our target for nitrogen use efficiency. If we look at somewhere like sub-Saharan Africa, they're 123. They're really good. Are they? They're getting 123 kilograms of cereal grain per every kilogram of nitrogen. The other side of this number is the amount of nitrogen removed per the amount applied. So they're removing about twice the amount of nitrogen that they're putting on. Where's that nitrogen coming from? Soil organic matter. So it's degrading the soil. So, you know, we're probably, in Australia, we're probably in the mid-range. We've got a really quite a good return on nitrogen, and because of our legume incorporation, we're probably a little better than some of the other places like East Asia or even North America in terms of our nitrogen balance. So, you know, one of the things I'd encourage you as advisors to think about doing that metric on your clients' properties. And think about where your farm lines up. If you've got, you know, a very low marginal return, then really you've got to think about whether you're putting on too much. And if you've got a really high return, maybe you should be putting on more. So just balance through that sum. But before you go on to that, you really have to think about if nitrogen is your limiting factor. And, you know, this goes back to the old story of, you know, the barrel with all the staves on it. I actually like these sorts of graphics much better. And the question you've always got to ask is, unless you've got the limiting factor addressed, nothing's going to happen. And it might be weeds, disease, cold, heat, etc. Might be water. But for soils, how do you know? Well, really the only way you know what the limiting factor is, whether it's too much or too little, is to do a soil test. And please, if you do a soil test, use an ASPAC accredited lab, a lab that's had certification for the technology that they're using, and use a FertCare accredited advisor or a system that's FertCare accredited. Reason being, that has known evaluations and it's independently audited to make sure that what the information you're getting is correct. So you get nothing for nothing, and really that's the story with nitrogen. The first thing you've got to do if you're working out your nitrogen your nitrogen management strategy is to have a target, and you need to do estimated nitrogen demand. And I mean, this is all agronomy 101, I'm sure, to you, but having a yield potential multiplied by a sort of a nutrient removal factor, which say is 22, it might be 20, it might be 24, depending on grain protein, by an efficiency figure, and you take away what maybe is available pre-sowing with a soil test, deep soil test, an estimate of mineralisation. That's a bit dicky, but you know, there's some algorithms out there. And the other thing you've got to think about is how much nitrogen's immobilised, and that might be a big thing this year as we go out of big stubbles into this year's crop. You know, it's around about a half a kilogram. I think it's about half a kilogram of nitrogen can get tied up, so per tonne of stubble. That figure's pretty flexible, but think if you've got a big stubble load, that is going to tie up some nitrogen. And that was the same last year. In fact, at Birchip, the estimate at the start of the season was that there was minus 12 kilograms of nitrogen in some of the paddocks, simply because the demand from the stubble the previous year. So if you do that sum for a 5-tonne wheat crop, you know, 5 by 22 by 2 minus, let's say, 50 measured, 50 estimated, 30 tied up, 150 kilograms per hectare. Don't be scared by that number, and I think that sometimes does scare farmers, particularly when you say, well, let's target 8 tonnes, and suddenly the number goes up to 220 or 230 kilograms. Just because you've got that target doesn't mean you need to do it, because you need to be a bit of a Texas sharpshooter. And what a Texas sharpshooter does is they fire the bullets and then go and draw the target round where the bullets hit. So you're always right. And you've got to review the demand as the season unfolds. And that's really the critical part of this demand curve, actually working out where you are as the season unrolls. And, you know, this is now the sort of general strategy is that we'd look at sowing as the season increases. We'd start to look at our nitrogen management in here between tillering and stem elongation to first flower, and we'd probably have 2 decision points about how much and what to put on. So just focusing on that in-crop nitrogen management, not particularly worrying about the nitrogen management pre-crop, but just like everything, timing's important. And it's really about, it's also, timing is probably the key, but we've also got to think about the place, whether it's soil and or foliar, the source, and there's probably 4 common sources that we'd use, UAN, granular urea solutions or maybe ammonium sulphate, and the rate to meet the unfolding potential. And think about this rule of thumb: 20 millimetres of rain is a tonne, which gives about 40 kilograms of nitrogen demand. So that's the sort of way the season will unroll, and that's the way the yield demand, the nitrogen demand will unfold. So let's just go back to this timing issue. The reason timing is so important is because it's between floral initiation and maybe 10 days after anthesis that grain number is set, and grain number is the driver of grain yield, and that's the one we need to think about. And any stress between, say, DC31 and 10 days after flowering will reduce grain number. And it's a little different for each crop, but, you know, between the biggest stress is just prior to anthesis. So in terms of nitrogen management, that's when we have to have the stuff there ready to go. And so at DC30 or so, probably in this crop, there's probably 30 to 50 kilograms. That's probably, its nitrogen demand is probably been met already by the nitrogen in the soil and maybe some mineralisation. And it's now time to review and revise our nitrogen budget. And how do we know where we are in that nitrogen budget? Well, there's a few tools you might like to think about. And one of the things, the second thing you've got to think about your yield potential, but the second thing I'd like you to think about is using N-rich strips in your paddock. You can do all sorts of fancy things. You can have plant testing, you can do NDVI with all these nice gizmos, but why not get the kid out on the spray bike with a tank of UAN before sowing or just after sowing and run them up and down, just a strip with a boom or with a urea spreader, and see if there's a response. If there's a response there, using these very sophisticated sensing tools, our eyes, then we've probably got we're in a situation where nitrogen's the limit. You can do the same for sulphur or phosphorus or whatever, potassium. But you know, if you're using, say, Green Seeker, they also recommend using an N-rich strip. And for me, I think this is probably the least sophisticated but the best technology on a paddock-by-paddock basis to work with your growers. So with that sort of thing in mind, and we've now got what are the options when we intervene in that nitrogen management situation. You know, I just want to draw some data from some work that John Midwood at SFS has been doing. And John, if I plagiarise you or I say something wrong, please jump in. But this was some work done at 8 sites as part of a GRDC project, a 1-year project only, or 6 months. And I just wanted to talk about the Victorian results. And basically the treatments were a couple of nitrogen rates, some timings, and 3 different products. And in terms of those 3 sites in Victoria, there's the yields: Inverleigh 5.1, protein 10, 11, nearly 10.5, Murnong 4.5, 7.9, 5.4 and 11.2. What jumps out at you there? Say again? Okay. We would say that we've left yield on the table because the protein content is so low. And, you know, we have this view about nitrogen response and protein response. And that is that as yield increases, you get some protein increase as you put more fertiliser on. As you get a bit more, you get another yield increase, maybe not so big, but a protein increase. And then once your yield has been satisfied, you get a protein increase after the yield. And that yield increase. And that also applies in terms of timing. The other thing protein tells us is where we are in terms of what we've left on the table. This is some data from Montana on grain protein versus relative yield. And what they're saying is that at 12.5% or a bit over 12.5%, if your protein was lower than that, you left yield behind. The relative yield was low. And really, even if you're in a feed wheat situation, think about using grain protein as a de facto measurement of where you've been with your nitrogen treatment. I know it's retrospective, but hindsight's 20/20 vision always. So, it is a good measure to check back on your nitrogen management. In terms of those treatments, I just put up one or two graphics. This is the zero, and the blue lines are the standard error around the zero, and it's 25 and 50, the different products. The first one's at growth stage 32, 39, 55 and 70. And in terms of yield, what do you see? Most of the early applications had a yield increase. Small increase, not great, but a small increase. As we went to the latest application, we got no yield increase. And Plant Physiology 101 says that's exactly what we'd expect. That is, the earlier you put nitrogen on, the more you stimulate grain number through tiller number, the greater the yield potential. But then, on the other hand, as you look at the same thing in terms of protein, again, the zero and the different timings and products and rates, you can get some stimulation of protein. You tend to get the highest protein, in this case with the highest N rate, at GS55. Beyond GS55, that is flag leaf, late flag leaf, you do get some protein, but the biggest protein bang is at 55 and a little around 55. How's that time, Toombs? Good. Keep going, okay. So if you looked at the means of all those sites in terms of yield and protein, certainly the highest yield was from the earliest treatments, and the lowest yield was from the latest treatments. The other thing about this experiment is these were all over basal nitrogen treatments as well. For example, I think the Inverleith site had 150 or so kilograms of N under it, so we added another 25 or 50. And the protein, the peak protein was around DC55. That's when we got our protein benefit. If you're waiting until ear emergence and beyond into mid-soft dough to try and push protein up, you've missed your yield and you've missed your protein, so you're wasting your money. We didn't get any adverse effect in screenings or bushel weights. This value here is the amount of nitrogen removed, which is the product of the yield and the protein, and basically you can use that as a de facto measurement of where your extra nitrogen has got to. So the late N, for protein, there's a window, but DC55 really is about that window. We've done similar experiments in other places, and it comes up pretty much all the same. The later you apply, you can produce protein, but really your biggest bang for your buck, the most efficient in terms of recovery of nitrogen, will be at your earlier applications. And so the summary of that sort of picture about timing is where should you spend your nitrogen money? And very simply, stem elongation and flowering. That's the target time that you should be looking to have your money invested in nitrogen. Sure, you can get some after flowering, some little bit of benefit. Say if you're trying to tick a durum crop into a proper classification, or if you're trying to push into a higher classification with a milling wheat, you can do that, but really the bang for your buck, yield is still king. So what about the other part, the form, foliar, soil or what? Now, there's been a little bit of work done on this over the years, and we know very simply that urea is by far the most rapidly taken up. It's a non-polar molecule, it's taken up very rapidly. Ammonium is a positive ion, it takes up quite rapidly too. Nitrate also is taken up, but a lot slower, and that's about the order of uptake. All those are limited by either toxicity in urea's case, or salt burn, or leaf area. That is, there's not enough leaf to capture that applied, so it actually ends up just dripping on the ground. The plant takes it up anyway. So that means timing's important. You can get some leaf damage. The worst effect is if you burn the flag leaf off. And that'll certainly raise protein, but the reason it's raised protein is it's reduced yield at the same time. So the worst effect is late. And the other point is that really, in terms of a canopy, you probably only get about 10 to 15 kilograms of nitrogen into that crop through the leaves. The rest comes through the roots. And if it does come through the roots, through the soil, even on the leaf, there's a potential for ammonia loss. So that occurs whether it's urea or ammonium. So the only really safe form in terms of reducing ammonia loss is to use nitrate, sodium nitrate, but that's about 6 times the cost of urea, so it's a cost issue. And you could use ammonium nitrate, and that'll blow the crop out of the ground. Source and timing, how do they interact? Again, there was from that experiment in the high rainfall zone, John's experiment. This is the timings. These are the 3 products: urea solid, urea liquid, and UAN. And the earliest response was with urea, solid urea. As we went later at DC 70, there was a significant effect where you used the liquids, but the best effect in terms of raising protein was around that DC 55, and it didn't really matter a lot which one you used, whether it's a urea solution or urea liquid. Okay, so, and this is another little trial done by Tim McClelland at Birchard. I think Tim's in the audience, so jump in, Tim, which looked at early application of a crop in the mallee looking to recover from end stress, and they also put a rainfall treatment on it. And basically, the question is often asked, how much rain do you need to safen it? Does it really make effect? Follow-up rain gave a 12% increase in yield, but it had a minus 3% increase, 3% increase in protein. But the point here is that in terms of yield, it didn't matter whether you used UAN as streaming nozzles, UAN urea top-dressed, UAN only sprayed on the interrow with flat fan nozzles or fluids with flat fans. It didn't make any significant difference. There was differences in protein, and basically the highest protein came from the streaming nozzles. So it's all about the right product. Sometimes if you're concerned about losses, you might like to turn to one of these products that has a urease inhibitor in it, and that certainly is a way of preventing some of the loss of ammonia, loss of nitrogen as ammonia. So what are some takeaways? First thing to think about is review where you are. How good was your end management? Think about the grain protein. How much yield did you leave on the table? If your grain protein's 8, you've left yield behind. What sort of partial factor productivity, how much grain for nitrogen and how much nitrogen for nitrogen did you get? If you're going to invest in nitrogen, do so. The best bang for your buck is between DC 35 and DC 55. If you want to change, late N might help you change grades, but you know, you need some luck there. You need a big canopy, you need a nitrogen deficient situation, you need subsequent rain, etc., etc. And for me, there would need to be some compelling reasons to move away from just top-dressed granular urea. There may be situations where you can meld it with some herbicide applications or other applications, but in terms of dollars per kilogram of nitrogen, urea is still this is the number one. And you know, you do need some luck, and sometimes you do everything right, but it doesn't work, and that's the situation where you've got operation successful but the patient died. And that's a very simple situation, is that everybody can go through the whole situation, and like last year you can get a frost and that's the end of it. But that doesn't preclude you doing the right management steps. So where to now with nitrogen? It's part science and it's part a punt on the seasons, and you know, sometimes you're lucky and sometimes you're not. So, Greg, that's where I'd like to finish. Thank you.